Hello everybody, and welcome to another exciting, hair-raising, fun-filled episode of Radiorama, where, as the name implies, I show you how to work on radios. And today we have a very ratty Admiral Model 288. Is it 288? Let's see. 288, yes. This came in. There was a guy that showed up one day at our museum, and he had a moving truck full of stuff. And anyway, I don't know what the situation is with this guy, whether it works or not. It's pretty rough, and I'm concerned that we have what appears to be a loose tuning condenser mount. I'm wondering if the PC board is broken. So I'm going to do exactly what you're not supposed to do and plug it in immediately and see what happens. Well, this is the first for everything. The alarm is permanently stuck on. I don't see any pilot light. Oh, God. What just happened? Oh, never mind. All right, I'm going to take it apart. Okay, so I've got a screw missing back here. That's probably why it's bouncing around like that. In fact, this screw came out when I took it apart. And it appears that there's not actually a pilot light here, or there ever was one. I've worked on one of these before and it did have a pilot light, so maybe this one got deleted, or maybe it's a cheap model. The tubes felt warm to the touch. We've got this nasty frayed wiring going to that output transformer. Ajax electrolytic capacitor. It's probably bad. Let me see if I can get the alarm to stop wailing away. Maybe it just needs a little bit of WD-40 or something to loosen it up. Alright, well, this is weird. This plate is vibrating. That rotor is probably seizing up. We have some audio coming out, but no radio, and the tuning condenser is stuck. Oh, never mind, it's hitting that screw. That's why it's not working. Let me pull that out of there. I get a feeling the capacitors are hosed on this anyway. Let's see. Get out of there. Crap. Stop filming. Yeah, the electrolytics are hosed. So I'm going to cut power, because I'm probably doing damage to the set as we speak. It's cold. Man, this thing's a piece of junk. But I have the next week off at work, so I figure keep myself pacified by working on junk radios like this one. Alright, this thing's nasty. Look at all the crap on this speaker. And by the way, I did do a great job of poking a hole in it when I disassembled it. But I took the clock out, the radio chassis out, so now the case is completely apart so I can clean it. I'm not going to do it yet until I can see if I can get this thing to work. Need to replace the 3 electrolytics in here, and according to it, there's 2 values. There's a 70 microfarad and a 30 microfarad. B, which is here, and A is common ground, so that means on the other side here is the other positive of the other value of the electrolytic. I'm going to dust this off and fix that hole. That bothers me. Well, unfortunately, this speaker's messed up. There's 0 movement in the cone. I get a feeling that whatever crap got all over the speaker caused the center core to rust. Oh, I'm doing more damage. Yeah, look at that. This thing's been in water. That's rusted. So that speaker's toast, so I'll need to replace that guy. Alright, so we need to remove this electrolytic can. First thing I do is I mark down one side so that if I take it out and I lose my place or forgot where it was supposed to go, I can stick it back in there and get my reference point. But I think I'll remember. There's 1, 2, 3 leads holding it in. And what I'm going to use is my trusty handy dandy solder sucking tool. It does exactly what the name suggests. You push this button and it uses a little bit of momentary vacuum pressure to suck away molten solder. You have to heat it up and then apply that. And what I'll do is I'll pull away the initial solder and then bend these tabs back and cut them. Got to be careful. This earlier era of PC boards is very fragile. This one actually is a little bit better because some of the earlier ones, they'd put the tubes directly through the board without having any sort of socket like this. Well, there would be a socket. It'd be a part of the board, but then the heat from the tube directly on it would cause this material to get brittle. This might be a little bit of a later model. In fact, let me see. Where's the knobs? I think it's worn off, maybe. Nope, there we go. Little triangles, civil defense. So it's post 1955, so the PC board is just a little bit on the later side. Maybe. All right, so we succeeded in pulling that out of there. Let's make sure we know what is what. Common negative. It's right here. 70 microfarads here, 30 microfarads there. And I have my two replacement electrolytic capacitors here. We have the 100 microfarad cap. The thing is, with electrolytics, as long as the value is at or greater the capacitance, you're fine. So 100 for a 70 microfarad cap is fine. Likewise, this is a 33, totally fine. In fact, it might even be a little bit more quieter. So what we're going to do is the two negatives of these guys, which are the stripe here, will share that common negative. And it's easy to like jump them over there. And we'll replace both of these guys and see if the radio starts to work again. I realize that that's going to be interesting because I cut all the cords here. What is what? What turns on what? Let's see. That's coming off the rectifier, I believe. Great. And where do you go? Just dropping everything. I'll figure it out. It's probably these two guys. Big fat wires. Jesus, I'm an idiot sometimes. Now I got the radio working, but of course the speaker sounds awful. That's barely a speaker. Let me see if I can find another speaker somewhere. Alright, well I found a replacement speaker. It's actually out of a Zenith. I believe the holes should line up. I think there's a standard for these guys. Let's see. Yep, they do line up. So what I need to do is drill the rivets out of the output transformer to take that off, because we're going to need to reuse this, and I'm going to have to find a way how to attach it to either the speaker or inside the case or something. I just want to make sure that the radio is sound and sounds good. I know that's like a horrifically lame joke, but I'm going to drill this off and tack it onto the replacement speaker and see if it works. Alright, here we go again. Got the new speaker connected. And
I wonder what it's gonna cost.
it works! Alright. So now that we know that the radio is going to come alive, I am going to proceed to clean the disgusting, filthy cabinet. Alright, so the next stage is to clean the cabinet, and I've soaked it in simple green cleaner. And for the knobs, what I tend to do is use just a little bit of ammonia and some warm water, not to lift years and years of grime. And I like simple green a lot. It's non-toxic, it's biodegradable, it even kind of smells nice. I remember we had an old tractor when I was a kid. The engine on it was absolutely filthy, and it cleaned it up so good that it dulled the paint. I don't know what it's made out of. I think it's citrus or something, but it works. Man, I've worked on a lot of dirty radios. This is one of the dirtiest. I had to scrub it like 6 times, get all the filth off of it, but it's certainly looking a lot better. In fact, it's a different color than I thought it was. So now that we've gotten the case clean, it's time to go back and pay some attention to the chassis. We have 2 more capacitors we need to replace. These 2 guys. And then as far as the radio being functional, that will be it. Then we also need to take the rotor assembly out of the clock so that we can quieten it down so it won't vibrate and make that god-awful noise. And then I'll find a way to mount this transformer. Let's see. Really all I need is just one. There's one hole maybe. I'll figure it out later. Don't have to figure it out now, but let's finish the recap job. And also I want to clean the volume pot controls and lubricate the bearing for the tuning condenser. All right, it's time to, well, first of all, I recapped the rest of the set and cleaned the volume control, lubricated the tuning condenser. And so now what I'm going to do is remove the rotor from the Telecron electric clock movement. It's this brass, what am I talking about? Copper drum. And it's a pretty ingenious design. The electromagnetic force in this electromagnet causes the internal workings of this rotor to rotate. And it's hermetically sealed so everything stays nice and clean. I have a bunch of these clocks in my house and they keep perfect time, and they've been running for 60, 70 years. To get it out, what you do is you loosen these 2 screws, and then this is hinged. And these will splay open, and you can just take the drum out. And it only goes in one way because there's going to be an output shaft. It's probably up here. So when you put it back in, it's pretty much foolproof. Also, another giveaway is the top will say Telecron. So we're going to take this rotor out and we're going to free it up. Even though it is turning, it is causing a lot of noise. I also don't understand why this plate was attached back here. In fact, I think I know why it's vibrating. That used to be foam. Now it's solidified nonsense. And that probably provided a cushion between this plate and this so that, you know, that's just amplifying the vibration that the rotor's putting out. All right, what we're going to do now is we've gotten the rotor out. I'm going to heat the drum with my soldering tip. And what I've done is I've put a little light machine oil into a tube that goes over the output shaft and seals it off. Sometimes you have to sit here for a few minutes to heat it up enough for it to start to boil. And what's going to happen is the heat is going to cause the air inside of this drum, which, as I mentioned, is hermetically sealed, to expand. And then what that's going to do is it'll push air past the output shaft. And you'll sit here and watch it bubble for a little while, get a lot of air pushed out of the drum. And then when we remove the heat, as it cools, it does the opposite. It'll contract and it'll suck in the new oil, and that should make it run smoother. Okay, you see here, it's like a bubble light. We're going to sit here for a few minutes and let this thing bubble away and push a lot of air out, because that air is going to basically cause a vacuum so that we can suck the new oil in, as I mentioned. Okay, so we've boiled a lot of air out of there, and what I do is I put a tiny little mark with a marker that shows the level of oil that it was at when it was heating up. And so the idea is I'll come back later and that oil level should have dropped, meaning that the drum has basically sucked the oil in. Sometimes it doesn't. So that's why I put the mark on there, to make sure that some stuff got in there. All right, so now it's time to work on the case. And I discovered this little thing. It's like an attachment for my drill. I used to get out here and do it by hand. And as I get older, it just kind of makes my hands cramp up. So I'm going to use the product that I've been using for years, Novus number 2, fine scratch remover, and use this guy. Does like basically an hour's worth of work in about 10 minutes. And that way we can get some of this stupid blotchiness and whatever off this case. All right, well, I got partially started, and we've got some discoloration in the plastic here, and I'm not sure if it's from heat from the tubes or if it's just UV damage. Looks like someone's been scratching this. Anyway, what I'm going to do is get out some steel wool and try to remove a layer to get down to some fresh plastic, and then we can buff that out. All right, we can see that quite a bit of oil's come down from the line, so I think this guy is probably lubricated. Yay! Welcome to day 2 of working on the formerly greasy Admiral. And what I decided to do, I went over to the museum this morning and I found another speaker that had the output transformer still attached. And when I started to put it into the back of basically the front plate, this guy is in the way. And I noticed that the original speaker had notches cut out here. So I cut out a similar notch on this one so that when we reassemble, we can do just like so, as all of our holes line up properly. So now that we've gotten that taken care of, I'm going to reassemble the clock. Yesterday, as you saw, I lubricated the mechanism. That should run a lot more smoothly. This one's a little bit different. There is a plastic piece that goes on the left side. Has these little buttons / depressions that lock up into the plate here. You want to put it in there just like that, like so on this side. And then this little guy goes this way, and you want to make sure that this little finger tab like touches down on the drum. So let's reassemble that clock mechanism, and then I'm going to hook it up to 110 and see if it's quiet. All right, well, we've got the clock back together. I'm not sure if you can hear that, but it's very quiet now. Anyway, that's going to make it sound like, it's not going to sound like an alarm when it's running, which is a huge improvement. All right, so the next stage is to add the oh-so-famous aforementioned audio input that I add to most of my radios, especially clunkers like this one. And we're going through the volume pot, and basically there's a top and a bottom to the pot. That means there's a section where our signal from radio comes in, and then there's a bottom, which is the ground. Sometimes you have to kind of look at it a little carefully. I can tell very easily which one is the top, because this is, you see we have these 3 connections here. That's clearly ground, so that means by default this is our incoming radio signal. And that goes to, eventually works its way over to one of the legs of the RF transformer. So what we're going to do is make a little cut right here. And what we can do is when we run the signal through, we can also have a switch wire that comes out of the back so we can turn the radio signal off and on so we don't pollute our audio. A lazy way to do it, which is not as satisfactory in my opinion, is you just tune the tuning condenser all the way to the right where there's no stations, but you're still going to hear static over the audio, and that's not nice. So if you're going to do it, might as well do it right. I've taken the old output transformer out of the circuit. I'm going to save it, and I just left the little nubs of where the old wires were so I know which is what. This is red, this will be blue. And what I'm going to do is go ahead and cut this lead here and test it and make sure that yes indeed that is really and truly killing my radio signal. And then I'll get something called an isolation transformer, which is one of these guys, and run the audio through this to the volume control, and that'll provide a little bit of a boost of a signal from the input device, and also guarantee that the user will never have any contact with any sort of current at all. All right, so I've got my new speaker connected, and I've powered it up. Perfect. No radio, just audio buzz. And I cut the little splice from that lead right there, or that trace, and we'll just run a little switch wire out the back. And what I'm going to actually do is get a wire, because sometimes that wire will act like an antenna. So I want to make sure that that's not going to be a problem. And then we'll go to the next stage, which is adding the audio isolation transformer. So the wire, as you can see, it is a little sensitive. I've made it overly long on purpose because I want to make sure that I can run it somewhere. I'm probably going to have 50% less wire. The shorter you make it, the less interference potential that you actually have. So now that we've got our switch wire installed, we know that the audio is going to run through, and the new replacement speaker and output transformer is working. Then we can proceed with the next stage, which is adding the audio input isolation transformer and its incoming audio. Okay, we're going to test this out. I didn't have any more 12 volt ratioed isolation transformers. I have 6 volts. Just going to see if that works here. Johnson family reunion has become an institution. They all wear the same
and red t-shirts on the front. It said these fireworks this challenge.
Certainly does. It sounds real good. All right, so it's time to glue everything into the cabinet. What I've done here is I have a short lead, the audio lead, and I'm going to mount the transformer probably up here because it won't fit on the board. And then I'll need to either see if there's holes already in the back of the cabinet, or I'll need to drill some holes for the switch, for the radio switch, as well as to run this 3.5 millimeter stereo jack through there. So let's put that together, glued up, and I'll show you what that looks like. Okay, so it's coming along here. I went ahead and put the clock back in, wired that up. We have the audio input devicey thingy, and it's working. We can, likewise, we can turn the radio on. There we go. So all that's left is do some final reassembly, and we should be good to go. All right, so it's all back together again. Unfortunately, I think due to however this was positioned in the sun, I wasn't able to get all of the blotchiness removed from the cabinet. But you know, it's not bad. It's certainly better than it was. And the fact that it can now be used again and not be thrown in the garbage like it was is much better. So, actually sounds pretty good. I think it helps that like it's basically sealed up in a cabinet, so you get just a little more bass response. I mean, granted, you're not going to win any audio contests with this thing. It's just a little crappy 5-tube radio, but she lives. I'm going to let it sit here and run for probably half a day just to make sure that nothing's going to break down thermally, and then it's going to be reliable. You can see the clock is super quiet now versus the horrific racket it was making before. And so I think it'll make somebody happy if they like this styling. We have this little switch here for turning radio back on, and we have the cable coming out the back here too. So there she goes. All right, everybody, thanks so much for watching. If you have any questions or comments, you can leave them down in the comment sections down below. I'll try to get to them. But until the next time radio comes across the workbench, I'll see you guys next time. Adios.